Hi everyone. This is presentation recording for Sprint 4 for Group Algo Avengers. And today we are here to present the final presentation for a capstone project. Our project name is EcoScan and it is a plant disease detection system. Next. So we'll be going through all the pointers, that is improvements, project description and problem statement, team agreement and personas, MVP and tools that we have used, machine learning algorithms that we have used, diagrams, all the sequential diagrams, architectural flows, sprint recap and project backlogs, user stories and acceptance criteria, test cases and sprint backlogs, burn down charts and retrospectives, that we have gone through all the sprints, application screenshots, and there will be a demo and APIs that we have used and technical paper. Our team members are, we have 8 team members, me, myself, Rudra, Omkar, Shriya, Ritika, Lokesh, Niyati, Uma, and Mukesh. We have assigned different roles to each team member, and one team member can have multiple roles as well. So from the previous sprint, that is sprint 3, we got some feedback from our professor, and we have made changes accordingly in this sprint. And some of them are the changes to the sprint recap, updated product backlog slides, fixed the user stories and story points, updated acceptance criteria, fixed test cases along with user IDs, and corrected the matrices and included the demo in the final presentation as well. Next. So the project description. We initially came up with this idea to detect these plant diseases based on a machine learning model. And we can also scale this project, but currently this is a web-based application which helps mostly targeting farmers to detect plant diseases and check what improvements can be done, whether it be soil or other improvements such as manure and all the other stuff. So we are trying to empower farmers to engage in this activity with the help of the website, and they can use the application. It is a very smooth application. They just need to upload a pre-existing image, or they can also get a real-time feedback. The team agreement, we came up with this team agreement. It is going through the team agreement. It is all the stuff that is meetings. Uh, if somebody is not able to attend the meeting, he or she should be letting everybody know in the meeting. The entire project should be divided into equal parts and equal responsibilities throughout the team members. Each team member should complete their respective work before the deadline. If they are unable to complete the work on time, the performance of the entire team is hindered. So in this case, a member is facing. Can we go back to the slide? Yes. So in that case, the we can make any improvements and we can work across teams. So we had a communication. The communication was done via WhatsApp groups and weekly meetings. We also had Jira tool that we use for tracking our tasks and epics and all the other features. And Google Documents was also used for this. Next. The personas. So personas are all the final end users that will be using the application. Eva is one of the personas. She is a progressive farmer and is deeply rooted in the rhythm of the seasons, guiding her farm through cycles of growth and harvest. And her interest lies in mostly sustainable farming. So this application is going to help people like Eva to make good choices of yield and save on losses. Next. Raj is a 30-year-old AI software engineer, and this can help him as well, as he will be constantly coding and testing the limits of artificial intelligence to serve the Earth's farmers. He sees the potential in every line of code to revolutionize traditional farming practices, and he can act as an administrator in this. Claire is a environmental policy advisor, and her interest lies in organizing educational workshops on sustainability, enjoying weekend family outings, and the goal for her will be to influence the adoption of sustainable agriculture policies that support and encourage the use of advanced technologies like EcoScan, our project. Our MVP was to make a disease detection system where a user can input an image, and the final output will contain the disease detected for the particular plants, the symptoms for that particular disease, and the precautions that can be taken against to solve the necessary, and what are the supplements that he can use to change the output. The tools that we use across the projects throughout the project are Python. So these are libraries and tools as well. So Python, NumPy, OpenCV, Keras, CSS, Jira, TensorFlow, HTML, Studios, and Git. We have used this in three major aspects, that is front end, back end, and management. So for front end, we have used HTML, CSS for building our website, Visual Studios for front end coding, Figma for designing. For back end, we have used Python, Keras, NumPy, TensorFlow for all the machine learning activities, OpenCV for object detection, Django to connect with the front end. And for management tools, we have used Jira, Microsoft Teams for daily meetings, WhatsApp for daily communications, and Git for sourcing the management of the code. Here on, Shreya will take over. Thank you.
Thank you, Rudra. So I will be explaining about the machine learning algorithm which we have used. So before going to the machine learning algorithm, let's understand like what is the database which we are using. So our database is Plant Village database, which consists of 84,000 RGB images, in which we have used 70% of them for the training data and the 30% of them for the testing data. The plant types which we are be using is going to be 14. And when we are showing the demo, you will able to understand like what are the different plant types which we are using. So number of classes on the model which we have trained is going to be the 38 models. So initially we tried to develop with the basic CNN architecture, but we were not able to do that. So we shifted to vision transformer model, which is good for image classification. And I will explain about like what are the different layers in upcoming slides. The matrix which we have used is accuracy and the losses. And to connect with the front end, we are using the Django as a framework. Next slide, please. So this is basically the images of the data which we are going to be working on. So this are all the RGB images. Next slide, please. So depending upon the images, we just have like class distribution, like which to check which has the most number of images which in our data set. So as you can see, the orange has the most classes in the data sets which we'll be using. Next slide, please. So before going to the actual model implementation, we have to like just have the data augmentation. So like I mentioned earlier, we are using the 70% of our data for the training, 30% of our data for the testing, and to have the proper standardization in our images, like from 100 to 100 pixel size, to give a uniformity across the data set, we are using the standardization process. And I will show in the code as well, like what we are doing in that. And to have you as you know, like to do image processing with the RGB images is going to be tough. So we are just scaling all the images to grayscaling so that it will be easy for us to have a machine learning algorithms. Next slide, please. So yeah, this is the basic architecture which we are using. So the model which we have implemented is with the help of the TensorFlow and the Keras. So our model is a sequential model which consists of a flattened layer, two batch normalization layers, two dense layers. So in one of them, we are using the activation function as relu, and for the next layer, we are using the function as softmax. And the name given for a model is vision transformer model. So this is the basic architecture for a model. Next slide, please. So this is the graphs which we would like to show about like how we have trained and tested a model. So training accuracy is 98.2% and the validation accuracy is 96.8%. So as you can see in the diagram, like the blue line shows the training accuracy and the orange line shows the testing accuracy, which we have done. Similarly, we have done it for the losses as well. So in which you can see the train loss with the help of a blue line, and the orange line indicates the testing losses in the data set and in the model. And next slide, please. So this is the basic code of like what we are doing. Like I mentioned, like for the data generation, we are using the different image and data generator in which we are like resizing the images, giving a proper width, flipping the images if necessary. All that is done with the help of a image data generator. And this is the code for the testing purposes in which we based on the prediction, like if we want to check whether it's a stage 1 error or the stage 2 error like the diseases, that it can be done with the help of this. This is the basic if else statements which we are implemented. So this is basically all about machine learning model. Further will be explained by Omkar.
Hello everyone. I will be explaining next about the diagrams. So we have multiple diagrams here. Let's start with a conceptual diagram or architecture diagram. So when a user is logging onto our website, he will basically start with the login process. If he doesn't have an account, he will create an account with the login ID and user ID and password. Then he will directly land to our home page. We'll show you all the things on demo as well. Once he land on a demo like home page, user has a multiple options to see. He can go through our homepage and find out the multiple options like getting the latest news about the agriculture and what is the latest things happening in the agricultural sector. So we are showing that also on our homepage. Then we have another page which shows about us page, which indicates that what we are like who we are and how what's the motto behind us to create this. The next we are also showing the area wise soil details and what are the crops which can be used for that particular region. The next we also have a detailed weather report with respect to the particular region. So we'll be showing that. And apart from that, next which is our MVP, that is disease detection page where user will upload the image, and next he will upload. Then our website will check if the image is correct in the correct format, and we will give him the feedback about what was the disease and what are the precautions he has to take and what are the symptoms. And after all this, we have also considered adding one extra tab, which is a history tab, where every like all the previous historical data will be stored, whatever he has uploaded on the website under his account, and then there will be a logout section. This is our conceptual and architectural diagram. Next is our sequential diagram. So basically, just what I explained right now, sequence diagram is this is the flow. So user comes to our website, he registers, then that registration goes to like user data goes to storage. We get the user data, we shows the authentication, a success or failure gives to a user, then user can go to our, this is related to MVP. So user goes to upload page, here uploads the message that is stored, uploads the image, it is stored on, the image is stored on our backend server database, and then that is where you send to ML model, it gives us a feedback, and then that feedback is sent to user, and we shows the user analysis, and meanwhile we also stores the analysis for future use cases of the user. Next is our class diagram. Class diagram consists of a user, farmer, crops, disease analysis, and images. And this is our ER diagram, interrelationship diagram, explains about how user and all the entities are interacting with each other. Like let's start from a user. So basically user as an entity, he has user ID, name, email, login, role and password. So once user login as a farmer, he uploads the image can be associated with one crop or multiple crops. So and it can also give us the association with the analysis. Even the crops uh, gives us like crop can send us like ML model sends the detailed report about the crop and what are the disease it is related to. So this is how your entity relationship model looks like. Next is a state diagram. So for a user logs in, he uploads the crop. Then once we upload the crop, we will detect if the image uploaded by the user is in a correct format or in a wrong format. If it is a correct format, it will accept the image, and we will try to match with the our data set, and we will give the user whatever the prediction we have. If the image is not matched, then we will give if the image is not matched, that means that we don't have the data on that particular image, or we haven't trained our data set or the database on that particular image section. So we will return the error that we don't have this exist we don't have the images in our database. And if the when user uploads the image, at that time if the format is wrong, we will again send back the error to the user that please upload the correct file. Further is, yeah, next will be explained by Niyati.
Yeah,
Thank you.
so like we'll be discussing what we completed. It's a quick recap of what we did in sprint 3. So basically you can see the story number 5. The user wants to see the stages of detected disease so that that user can understand the severity of it. Then the other story is the user wants to verify if the image is right so that they can get the results accurately. And the 7th story is the user wants to receive a prompt if the image is not in a correct format, so they can re-upload the image which is in correct format. The 8th story is the user wants to know if the crop is available in the database, so they can check if the crop availability in the database. And the last one is the user wants to check, the user wants the crops and growth conditions for the area, for that area where they live in, so that they can be well prepared for the crop cultivation or plant health. Next. So the product backlog from the sprint 2 onwards. So the shaded in blue ones are the sprint 2 backlog. So the first story is user wants to upload an image of a plant leaf to detect diseases so that the user can view the diagnosis of the plant. The second story is the user wants to receive detailed information about the detected plant disease so that the user can find a cure to the disease. And the third is the user wants to view prescriptions and suggested supplements for the disease so that they can take those necessary steps to treat the plant or crop. And the fourth story is the user wants to know the various cures and preventive measures for the detected disease so that they can take necessary precautions or from the disease. And the shaded in yellow is the sprint 3. So as I mentioned in the sprint 3 recap, the stories are like they want to check the stages of the detected disease so they can understand the severity and the image format. Next slide. Yeah, and like as I mentioned in the sprint 3 recap, like each story is like based on the format, the crop if it's there in the database, and the information about the information about in that area about the crops and the growth conditions. And the red shaded is a sprint 4. So the 10th user story says that the user wants to see the latest news related to agriculture and farming practices so that the user can get knowledge or information about that agriculture practices. And the 11th story is to receive notifications or updates about the uploaded plant reports the user uploaded so that the user can be informed about the updates as soon as possible. Next slide. And the 12th story is the user wants to explore and learn about new farming technologies and practices so that the user can keep themselves updated with the latest technologies in agriculture. And the 13th story is the user wants to see the latest weather reports related to their area so that they can get information about the weather there. And the 14th story is to create an account. They want to create an account for the website so that they can use it, like they can log in and see their information. And also the user wants to log into the website so that they can store their information. And last is the user wants to log out so the information and reports are secure. Thank you.
Thank you, Niti. Hello, everyone. This is Mukesh, and I'm here to explain about the acceptance criteria of our project. Here we can see we have few user stories and their respective criteria, which are in sprint 2. So here is one of the scenarios where a user wants to upload a leaf image, where he can go to the EcoScan website and should be able to find an upload button so that he can upload an image so that he'll get his picture detected for diseases. Here its criteria is the EcoScan website will will be able to store the image for processing. This comes under the disease detection feature. And one more user story where a user wants to know detailed information. So given I'm a user, when the user uploads the image, I should be able to get the detailed information about the disease, and our EcoScan website will store the information about the disease. And this comes under the disease detection feature too. So one more case scenario where a user wants to view prescriptions and supplements about the plan. So here, the user may view the prescriptions and supplement suggestions for the disease being detected. Our EcoScan website will provide the information about prescriptions and supplements needed for the detected disease. And this also comes under the disease detection feature. One more story where the user wants to know preventive measures for the detected plant. Given that I'm a user, I want to know the steps to be taken to cure the detected disease, and also about the information of the supplements and stuff. So this comes under the disease detection feature, and here also our EcoScan website will provide the diagnosis for the disease. Next slide, Omkar. Here are a few other user stories for Sprint 3, where a user wants to look at the disease stages being detected. Here, as a user, I want to know about all the stages detected for the particular disease. Our EcoScan website will provide diagnosis for the disease, and this comes under disease detection feature too. Here, one more user story where a user wants to check if he uploaded the right image format or not. So that as a user, I want to check if I uploaded the right image format or no, so that I can re-upload in the correct format. Here, our EcoScan website will check the image if it's uploaded in the correct format or not. This comes under user interface feature. And one more user story where a user wants to know if the image uploaded is correct or not. Here, after uploading, if he wants to upload an image, he wants to receive a prompt or notification knowing that the image format is correct or not, like the image lighting or maybe the placement of the picture. So here our EcoScan website will check the image and its format and send a prompt or notification knowing him the image format is not correct. This comes under the user interface feature. And one more user story where a user wants to check crop type existence or not. Here, a user want to know about the image of the crop selected is available in the data set or not. In this case scenario, our EcoScan website will check if the particular crop is present in the data set agricultural information and give him the details. This comes under the image checking database feature. One more scenario where a user wants to know about the growth conditions about his area. Here, a user wants to know about the crop and its suitability in his area and how its growth will be. Here, our EcoScan website will give information about all the details of the crop suitability related to his area. This comes under the agriculture information feature. Next slide, please, Omkar. Here are the few case scenarios which we have added in Sprint 4. Here is a scenario where it explains a user wants latest news related to the agriculture. Here, as a user, I want to know about the latest news or maybe the trending topics around the agriculture, wherever we want to. So here, our EcoScan website will provide the latest news based on the agriculture. This comes under agriculture feature detection. And one more user story where a user wants to receive notification about his plans. Given that I'm a user, I want to get notified about all the reports, all the data, all the plan pictures being uploaded. I want to receive every information as a notification. And here also our EcoScan website will send notifications related to his uploads. This comes under the notification system feature. And one more user story where a user wants to explore and learn about farming technologies. So here as a user, when I want to explore or learn about any farming techniques or practices, our EcoScan website will give information about the new farming techniques or some other methods which will help the user. So this comes under the agriculture information feature. And one more case scenario where a user wants to see the latest weather reports related to his area. When a user wants to see the latest weather reports in his area, our EcoScan website will provide information about weather reports related to his area. And this comes under the weather feature. Next slide, please, Omkar. Here are the last three user stories. Here a user wants to create an account and log in using his details. When a user wants to create an account and keep his account private with his login credentials, our EcoScan website will be able to create the login credentials. This comes under the homepage feature. One more user story where a user wants to log into the website to store any information. Here, when a user wants to log in and store any information about his plant or any other data, our EcoScan website will be able to log him in and store the information given. This comes under the login feature. And here is the last user story where a user wants to log out and secure the information if any given. So in this case scenario, he wants to log out from an account to secure his information. Here our EcoScan website will log him out and by securing all the information given, and this comes under the logout feature. And about the sprint summary, our teammate Ritika will explain about it.
Thank you, Mukesh. So I will be taking forward the sprint summary. Can we go to the next slide? So here we have the summary for sprint 2. We see that we have 4 user stories for the sprint 2, which sums up to 16 story points. So the first user story was basically of regarding uploading the image of a plant leaf so that the disease can be detected. And so this is basically in the template of as a user, I want to upload an image so that I can view the diagnosis, and this has been placed under the feature of disease detection. Second user story has been given 3 story points so that so that as a user can receive the detailed information about the plant disease, and he can also find some cure to the disease. Coming to the next one, we have to view the prescriptions and suggested supplements so that the we can supplements for detected diseases so that the particular steps can be taken for the crops, and that has been placed under disease detection, and we have been given 5 story points for that as it was a bit of a job. Coming to the last one, in the sprint 2 we have various cures and preventive measures that can be taken for the detected diseases, and it has been placed under disease detection. Even this has been given 5 story points. Can we have the next slide? So this is the burn-down chart for sprint 2. Here we see that a sprint 2 began on 22nd of Feb and ends on 9th of March. So initially we were lagging behind the dates that were assigned, but as the days passed we did try to finish some before and some on time, but at the end of the sprint we were able to complete on the day that all the tasks were assigned. So can we go to next one? This is the sprint 3 one. So here we have 5 user stories which sums to be 24 story points, and here we have the main user stories are to see the stages of detected diseases and see if the image that the person is uploading is the right one so that they get the proper result, and if it's a wrong image then he or she, whoever uses it, gets a notification saying that the image which you have uploaded is wrong and should be given in a correct format. So both of these come under the user interface. The next one is knowing about the crop, if the particular crop is available in database, and so that the person can check the availability. The next one being the crops and growth conditions of the particular area so that the person can be well prepared for his crop cultivation. That comes under agriculture details. Can we have the next slide? So this is the burn chart for sprint 3. Here we see that we try to complete most of the tasks before time, and some only, I guess, during a particular time we were lagging behind, but then again we somehow managed and completed all the tasks on time. The next one will be taken over by Uma.
Thank you, Ritika. This is Uma Maheshwari Adala. Here I will explain about our Sprint 4 backlog. Here we have 7 different user stories, and each has different user points depending on the workload needed for the particular user story. And our first user story comes to as a user, he needs to see the latest news related to agriculture and farming practices so that he can get the knowledge or information about the agriculture practices. It comes to agriculture news future. And the second one is when the user receives if the user wants to receive notifications or updates about the uploaded plant reports, then he should be able to get the updates as soon as possible, which comes to notification system. And when a user wants to explore and learn about new farming technologies and practices, he should be able to keep himself up to date with the latest technologies in agriculture. It comes to agriculture information feature. And when the user wants to see the latest weather reports related to the specific area, he should be able to get the knowledge or information about the weather. It comes under weather feature. And when the user wants to create an account on the website, he should be able to create it using his email or phone or password. It comes under login and authentication. And when the user wants to log into the website, he should be able to log in and store his information. And when he wants to log out, still his information and reports should be stored and he should be able to log out. Next slide, please. Yeah. So here are the stories and acceptance criteria for our sprint 4. Here we clearly mention the criteria and summary, what the user is expecting and what we are working towards and what the expected result should be and the features they correspond to. Here, when the user wants to see the agriculture news, just like I mentioned in the previous slide, everything will be done accordingly. Next slide, please. Here are the remaining stories of the sprint 4. There are the total of 7 user stories, and each feature corresponds to each acceptance criteria, and they will explain about what the criteria is and what the user is looking for. Next slide, please. And here are the user stories that we created for each user. Here are the test cases that we created for each user story. And the test case ID and user story ID, they correspond to each other. And here the first functionality to be tested is agriculture news. When the user wants to see the latest news related to agriculture and farming, then he should be able to see the information. And this test case is completed successfully. And the second test case is in the notification system. When the user wants to receive the notifications or updates about the plant reports, then he should be able to get the information. And the third functionality is when the user wants to explore and learn about new farming technologies and practices, then she should be able to get the information related to that. And when the user wants to see the weather of the specific area or about the area he is living in, then he should be able to get the information accordingly. And the next one is login and authentication. Here the user should be able to log into the website using his email or phone and password. And the user should be able to log in successfully and he should be able to store the information. And when the user logs out, then he should be able to store the information. And all these 7 test cases correspond to 7 different user stories were passed successfully. Next slide, please. Here are the stories that we completed in Sprint 4. As I previously mentioned, all the user stories which comes to 28 story points, which corresponds to different features like agriculture news, notification system, agriculture information, weather, login and authentication, login and logout. All the stories were completed. Next slide, please. So here are all the user stories we completed in our project, and we shaded the user stories into 3 different colors to differentiate between sprint 3, sprint 2, sprint 3, and sprint 4. So the sprint 2 comes to 16 story points, sprint 3 comes to 24 story points, sprint 4 comes to 28 story points. So which totals to 68 story points, and we completed all the stories successfully. Next slides will be explained by our teammate Omkar.
Thank you, Uma. Next slides I will be discussing about matrices. So as Uma mentioned, we have completed all our story points, and for the sprint 4 we had total 28 story points which were distributed into 7 user stories. And this is our historical average chart where we had a sprint 2 we had 16 user story points. For sprint 3 we had 24 story points, and for sprint 4 that was 28 story points. We have completed all of them for all the sprints. And this is the burn down chart for our sprint 4. Initially we were little bit facing some issues with login authentication part, so we were a little bit lagging, but then we figured it out, and then most of the time we were ahead of our curve, and at the end we completed before time. So it was a really good sprint, as we have already, like, we were able to deliver everything on time, I should say, before time. So it was a really good part for us. Next is, this is the average burn down chart for all the 3 sprints. So it really indicates that initially we were getting together, discussing the things, and we were getting on together on team as well. So it took some time for us to get together and discuss and work collectively and get used to with the latest technologies as well. But later we had a completely a constant chart with respect to burn down chart for the average 3 sprints, and this was the completed to committed ratio for our sprint 4. This was 28. There were committed 28 user stories, and we have completed all of them. So we had 100% ratio.
Hello everyone, I will be telling about the retrospective part. So next slide, please. Yeah, here is a screenshot of the retrospective part. Like as we did in every sprint, even in this sprint, we went through the retrospective. So we use like idea boards platform to use this. I have like a lot of points went for what went well and what can be improved. So we have sorted it like using the votes, like the points which get like major votes. We kept it in the top manner. So next slide, please. Okay, coming to what went well, achieving our goal and getting the desired result. Yeah, of course, like we get the desired result, what we have thought in the front, the thought in the initial stage of the project. And coming to the next point, Jira and GitHub updates. Yeah, in this sprint, we are very perfect in these updates, like in Jira and the GitHub. So completing task on both front end and back end, yes. And coming to the last point, work well on the constructive feedback given by professor. These are the major points which have like a lot of votes by all our team members. And the next slide, please. Yeah, what can be improved? So we considered these things like in our future projects or like upcoming professional life. So we thought like early sprint planning should be the major one, and we should improve a lot in that point. And the second one is more research on algorithm that is used. Communication can be improved for upcoming projects and assign responsibilities well. Next slide, please. Yeah, action items. So yes, of course, appreciate each other efforts, and as a team member, we achieved it. So we were very happy, and of course, we deserve this celebrate and party points from our team members as we are with the successful project. And the next slide, please. Project demo. Yeah, we have made a demo clip on the whole website. Like we've made a video on each and every page of the website, and we can see this website link in our GitHub wiki page. Next slide, please. Yeah, here is the link for the YouTube channel, so everyone can see the demo video in this channel. And next will be continued by Rudra.
Hi everyone, we are here today to record our Sprint 4 demo, and Omkar is sharing the screen, and the team will go through all the aspects of the project.
Yeah.
So we are moving on to the logging in and authorization. If you are already a user, you can log on with your credentials, or else you can go and register.
Thank you, Rudra. Yeah, hello everyone. I would like to introduce our user authentication page. As this is the initial page we are like every user gonna go through. So this is like simple and everyone can understand. So this is our login page. Here we can log in if we are like an existing user in the website, or we can go through the register here option for a new account registration. So when we go through the register here option, here is the page where we can enter our details and we can create an login in the website. So here we have we have displayed everything easy so that everyone can understand like what are the things should be included in the username and the password. So in password, like we can keep the strong password or we can take the session from the browser. Yeah. After entering the username and the password, we should just confirm the password and go through the register. That's it. Yeah. Now, after pressing this register, yeah, here is the account created for the user. So next, like Mukesh gonna continue.
Hello everyone, this is Mukesh. So I'm here to explain about our homepage. So here you can see the first page. It's like just a motive we're explaining about in our project. It's like I'm planting a tree. Can you move on, Umka? So as our application is about the plant detection disease, here you can see a few samples. You can scroll on, Umka. A few samples about few plants like lemon, pomegranate, kiwi fruits, apples. So we have shown some few samples so that the user can like put any plant image to get his disease detected. Can you move on, Umka? And here is some few numerical reports about few agriculture sectors and scroll on, Umka. Yeah, here in this page, a user is supposed to see the latest news related to the agriculture or about the planting from his area or related to his area. You can go on, Gaurav. Yes, our teammate will explain about the about section.
Yeah, hi everyone. This is our about page, and here we see that we are explaining what exactly our project is doing, that is EcoScan. And on the right hand side, we can see about the graph regarding the seeds growth, economy, and planting. Can you just scroll down? Yeah, and here we have the team of our project. So this has all the 8 members of our project. Yep, and that's it for the about page. The next one will be explained by the team member.
Hello everyone. So this is our soil page, and this if a user wants to explore different areas of the cities, because we know every state has a different soil type. So here we have, just depending upon the soil type, we will give them the what are the soil production which they can do. So based on the California, you can see it has a sandy soil. So based on that, you can have potatoes, carrots. Can you scroll down? Peanuts and watermelons and peppers. So using that, the user can find which of the soils are suitable for the crops which they want to do. Similarly, you can look for the Illinois as well. So as the soil is different, as you can see, there are different types of crops which we can agriculture. So which are tomato, lettuce, apples, and grapes. So this is basically the soil section, which will give the basic idea about the soil, and depending on that, the seeds which they can plant and the disease they can detect for the plants. And next will be explained by Niyati.
Hello, so this is our weather forecasting page. So on this, it will give us basically state-wise information about the weather in that state. So for example, California, it will show us the maximum temperature there in Celsius, and then the minimum temperature, the humidity, pressure, and weather report. So similarly, we can check for other states as well. For New Jersey. So for New Jersey, this is the temperature, 14.3, minimum temperature 11, humidity 89, pressure 1020, and weather report is it's mist. Next.
So hello everyone. So I will be explaining about disease detection or MVP, and this is our landing page for a farmer. He will be able to choose a photo of any plant which we have to detect. Just for example, let's go for the grape. We can select an image from our repository or any of our local folder. Then we just have to submit, and once we submit, we'll get detailed report about the plant. That is, currently we have sent the grape image which has ESCA and black measles as predicted diseases, as well as this is a detail about what we have detected about the disease and how it looks and whatever features we can extract from that. Apart from that, we can give the symptoms and precautions, as well as what are the supplements we can tell them. So we can check for another plant as well. Let's go for the peach. Once we check for the peach, we will get the similar results for the peach. So we have a peach which has a bacterial spot as a disease. It has details about that particular disease. We can also get the symptoms and the precautions a farmer should take, as well as what are the supplements we can provide. For the next, let's check, since we have checked 2 of the plants right now, we can check one more. so that it will be, let's check for the con. Once we submit for the con, we will get the detailed report about the con as well. And next will be explained by Uma. That is our history.
Thanks, Omkar. So, as our teammate Omkar explained, when we upload the image of a deceased plant, here considering the leaf of the plant, it will give the description of the disease and the symptoms and the prevention and also the supplement name. Here, Omkar uploaded 3 different types of disease plants. So we have 3 different types of disease names, and each has its disease, and it explains what kind of disease it is and how it looks. And also prevention, what they can do and how long will it take. Everything will be given for the given disease.
Yeah, basically we are storing all the images and related history of all the images which we have already found, all the prevention measures and history of a user which he has found. Okay, that's it from our end. And here a user can log out. Before logging
So
out,
as
just
So as
go
we
for
can see that apart from the MVP, we have multiple features as well, whether it be news related to agriculture or other weather forecasting or other tools. This will help the end user make their experience much better. Thank you.
Yeah, and we are back to our original page where we can log in and check. Let's log in with my previous credentials. So we checked for a few of them previously as well. That time we checked for 2 of them, and here we can see the previous reports also. Okay, thank you. Thank you, everyone.
Thank you.
Thank you.
Thank you.
Thank you.
Thank you.
You.
So these are the application screenshots. Next slide. This is the login and the authentication page for the user. This is for the end user. It is either login or register if you don't already have an existing account. Next. This is the home page for our application. Next. The homepage consists of all the plants that we have added for our database, and these are some of the plants that this is marquee slider, and you can see that plants like pomegranate, lemon, orange, apple, strawberries, etc. are present in the database for the disease detection. These are some uh, industry standard numbers, and they talk about agricultural information and news reports. So we have used APIs for news. Uh, why to choose our application? Because this is a leading software where farmers or end clients can come up and understand and make better choices for their yield and grow better. This is soil information. We have used this and gathered information from API as well. This is related to particular regions. This is the weather forecasting for regional weather forecasting based on the user's location. This is our MVP. This is the screenshot to our MVP. As you can see, when a particular user puts in an image and the disease is detected, we can see that the predicted plant disease class and the class stage 1, or all the other details related to the disease, the symptoms for the disease, how that those diseases are caused to the plant, the precautions that can be taken by the end user, and supplements to be used to eliminate the diseases. This is the history for the end user if they create an account. If you don't have an account, you can also you can still go and check, but you won't be able to see the history. If you already have an account and you are logging in through the account, you can see all the historic information on your previous searches. So mainly we have used three APIs that include agriculture news API, weather forecasting API, and authorization page API. The benefits for agriculture news API are like supporting information and decision making for farmers and agribusiness users, and that encourages continuous learning and industry awareness. The weather forecasting is primarily for regional weather forecasting and all the other details such as humidity and r- the chances of rain. And authorization page includes the protection sensitive user data. So user can store their data and it will be protected through their account information. This is the GitHub link to our project, and you can go ahead and check our project and download the necessary libraries and use it for your convenience. We have also uploaded the technical paper on our GitHub. Here is a sample screenshot for the technical paper. You can see the whole paper on the GitHub link. And thank you. Thank you everybody to listen to our presentation.
Thank you everybody for this collective effort, and we have achieved our main purpose for this group project. We have completed all the MVP, including MVP. We have completed all the features and implemented all the features. Congratulations, guys. Most importantly, thank you for working collectively and resolving all the errors which we were facing every time. Thank you.